So, we live in a world that's surrounded by analog signals. Our eyes read light that's coming in waves. We hear sound that's coming in waves. The natural world is all in the analog world. But we actually live in a digital world. Everything we manipulate, we move around, are all digital signals. And so one of the things we're going to think about is how did we convert those analog signals into digital signals? And when we do that, we have to count. And when we're counting things, we have numbering systems. And if you think about numbering systems at the moment, we have the decimal system, which is the one we use for most things, but we also have the binary system, which is what the computers talk. In the past, we've had numbering systems that are based on base 10, base 60, base 20. So the idea of using different bases is as old as human history. If we think about bases, we have numbers. If we say 10, right? We think 10, but in reality it's 1, 10, and 0 ones. Just as 11 is 1, 10, and 1, 1. In the past, if we think about Roman numerals, they started out going 1, 1, 2 slashes for 2, 3 slashes for 3, and if you keep going, it starts getting very complex. So they had a 1, a 5, and a 10, right? Or an X for 10. And they would do 1, 2, 3, and then if doing 4 slashes, they would do an IV, and that's take this number and subtract this number. And then they would do 5 things, and then they would do 6 things, and 7 things, and keep going like that. So there's no place order except numbers next to each other. In the numbering systems we're used to, it's called having a regular base. And if you use base 10, again, if we do 203, that's 2 hundreds, 0 tens, and 3 ones, right? Of course, we're all used to that. Learned that in 3rd grade. But what we're really saying is this is the base time to the power of 1, to the power of 0. This is the base to the power of 1. This is the base to the power of 2. So it's base times 0, base times 1, base times 2. And to the right of the decimal place, it's base times minus 1, base times minus 2. And in base 10, that means this is 1s. These are 10s. These are 100s, right? And these are tenths, and these are hundredths. And so when we do 203, we're saying 2 100s, 0 tens, and 3 ones. But if we do it in math, it's 2 times 100 plus 0 times 10 plus 3 times 1. And that gets 203. So if we're doing all decimal, it always sort of makes sense, and you're like, well, yeah. But if we did the same thing and say in binary, it would be 2 to the 0, 2 to the first, 2 to the second, 2 to the minus 1, 2 to the minus 2. Now, anything to the 0 power is equal to 1. And then 2 to the first power is 2, and 2 to the second power is 4. So if we had a number in binary, 101, it would be 1 4 plus 0 2s plus 1 1, which is 5. And so this is the powers, but they're equal to in decimal. And of course, if we do 2 to the minus 1, it's 1 half, and 2 to the minus 2 is 1 fourth. So we have these different regular bases that we've used. And of course, as I said, we've had other regular bases that have been used in the past, like base 60 or base 20. The Mayans used base 20. Now, normally, what you need to do is have a different symbol for each, whatever your base is. So in base 10, we need 10 symbols, and that's 0 through 9. In base 2, we need 2 symbols, which is 0 and 1. one of the things we're going to work on is hexadecimal or base 16, and so we need 16 symbols. Now we do 0 through 9, that gets us 10, and we need 6 more, so we're going to use A, B, C, D, E, and F as well. So these regular bases are used all the time, and we're going to learn about using those in binary computers, decimal for humans, and as a go-between we're going to use hexadecimal. Now those are regular bases. Now there are non-regular bases, and these are things where the different places are different bases. So we might have base 2, base 10, base 16 as we go along. Now you say, well, that's the silliest thing I've ever heard. But we use one of those every day, right? So we have base 60 for seconds, base 60 for minutes, and then base 12 for hours for days, right? The Mayans had a calendar that's called the long count, and it was a mixed base system, and it was actually the one that we learned about in 2012 when the world was going to end because it was changing over. It was one of they had 3 different calendars. It was one of their calendars that used the mixed base system. And it was, again, base 20, and then there was base 18 in there mixed in as well. So not all base systems are regular bases. Regular bases have the same base for all the places. Mixed bases have different spaces. Each space may have a different base in it. Of course, you need to know what those are. You can't tell just by looking at it. As I said, generally, you're going to need a different symbol for the number of bases. But you can also do some sort of mix between like the Roman numerals and the regular bases. And that's what the Mayans did. So they used different symbols. They used dots and bars and a shell. And they, instead of going left to right, they went up and down. So if you wanted to do, that's 3, so that's 20 to the 0, 20 to the first, 20 to the second. So that's 3, 20 to the seconds. If they did a bar, it was 5, 20 to the first. And if they did a shell, it was 0, 20 to the zeros. And of course, if they added 2 dots, that was 7. That was 5 plus 2, which is 7 times 20 to the first. So regular bases have been around for a long time, and they aren't always left to right, and they aren't always used with the same number of symbols as the base. Generally they are, but not always. The Mayans are a good example of that. As I said, the numbering system we're going to use are binary, hex, and decimal, and now we're going to learn a little bit how to convert between them.